Acceleration is defined as a change in velocity over a change in time. But if we're considering two-dimensional motion, we have to be careful with vectors. And so acceleration is a vector. It's got direction as well as a magnitude. And velocity is also a vector. So how do we deal with that? We generally think of acceleration as speeding up or slowing down. And so if we think about this as a final velocity minus an initial velocity, okay, and let those be vectors, divided by some time interval, and draw our velocity vectors, well, if our final velocity is bigger than our initial velocity, so if this is our initial velocity, and this is our final velocity, then final minus initial is the same thing as final plus a negative initial, which means I would reverse this one. This is negative VI, and I'd place that on the tip of the final, and then I'd go from the tail of the final vector to the tip of the, or tail of the first vector to the tip of the second vector. In this case, it's final velocity to the initial velocity. So my acceleration is proportional by the time interval to this, and so this is my delta V, that vector right there, and delta V is equal to the acceleration times the time interval if I just multiply the time up. So the time is just a scalar, so it will just scale this size to make it appropriate units, but the direction of this acceleration would be forward. So we find that the acceleration, if it's speeding up, the acceleration points in the direction of the velocity. If it were slowing down, then this vector would be smaller than this vector, and so this would extend beyond and the acceleration would point the other way. And so we can conclude that the acceleration can come from a speeding up or a slowing down. But on the other hand, what if the velocities are the same size but change direction? So we still have this rule to apply, okay? But what if we have this case? Let's have the initial velocity being like that, and then the final velocity being like that. Same size, okay, but pointing in different directions. So here's point 1, here's point 2. It's coming in, and it's coming out, like that. Alright, and so let me write my initial and final. Okay, well, I'm going to need to reverse this and then place it on the tip. I'm going to do that in one step, so I'm going to come this way. So I've reversed this and placed it at the tip here. So this is negative V initial. And what is my acceleration? It's non-zero. Okay, this is delta V. And then again, delta V is proportional to the acceleration times the time interval. So that is effectively, besides a scaling in length, that is effectively the vector indicating the acceleration. So we got a non-zero acceleration even though the speed was the same. It didn't change speed, it just changed direction. So what's important is when we're talking about two-dimensional work, our acceleration can come from either a change in speed or a change in direction.